Okay, now very important where you have to apply the double angle formulas. Now these are the double angle formulas. So sin 2x is 2 sin x cos x. Your cos 2x is cos square x minus sin square x. So I'll try to apply this. Okay, and try to get everything in terms of x. So if I apply the identity, I'm applying this sin 2x identity. I'm applying this identity. So that will make it 2 sin x cos x. And for this one, I'm applying this identity. Cos 2x is what? Cos square x minus sin square x. Correct? Get all terms on one side. So 0 is equal to cos square x minus 2 sin x cos x minus sin square x. Correct? Now what happens?
I don't know, sir.
Can you split the middle term?
I guess. Yeah.
It won't help.
You can take out x.
But other than doing this, what you could have simply done is, sorry, I made a mistake. You could have simply, I realize it now, you could have simply done what you know? Sin 2x upon cos 2x is equal to 1. Divide both the side by cos 2x. Now use this formula. What is sin x over cos x?
10.
10x. So what is sin 2x over? What is that? Tan 2x is equal to 1.
And then what do you do?
You adjust the domain. Because of this 2x.
Oh.
Correct?
Then you solve.
So 2x is equal to tan inverse 1. 2x is equal to now all silver teacups. Your tan is positive here and here. So that's what? Pi by 4. And how many 5 by 4? 5 pi by 5, you remember?
Yeah.
5 by 3 pi by 4, 5 pi by 4, 7 pi by 4. So pi by 4, 5 pi by 4. So x is equal to pi by 8, 5 pi by 8.
But sir, still look at the original domain.
What you're going to do is use the double angle formula, because it's better that we combine this. So this is your sin 2x is 2 sin x cos x. So 2 sin x cos x I'll write as sin 2x. So I'll write this as sin 2x. Okay. So once I write this as sin 2x, so that means my angle has become 2x. So that means I'll multiply third by 2. Correct? So that's the domain for my 2x. So 2x is equal to sin inverse root 3 by 2. So what we are going to do is, now we have to look at all silver teacups. So when I look at all silver teacups, my sign is positive here and here. My reference angle is 60 degrees. Correct? So this is 60, this is 60. So if I'm looking at my answers, my 2x, sine inverse of, so first you'll start with all this. Negative. So what will this be?
Negative 240.
Negative 180, yeah, minus 240.
Negative 300.
Then from here you go to here, negative 300.
60.
Now you go positive.
120.
So this is 60 and this is 120. Correct? So your x will be minus 120 divided by 2 minus 180, correct? 30, correct? And 60.
So how 360 negative?
360 negative, no? From 3,
no,
300. Why 360?
So that's what I said. So that's what I'm saying. Why 360?
So 300.
I know.
Okay. So that would be what? Minus 150 this will become. Yeah. So that would be x is equal to pi by 180.
No, you don't need to do this.
150. No, no, you don't have to do that because your domain is in reality.
You say it's good to do it, then I'll be like, no.
So what you do in this is your sine x over 2, you take the cos on the other side. So this is cos x over 2. You divide sin x over 2 upon cos x over 2 is equal to 1.
Okay.
So tan
x upon 2.
tan x over 2 is equal to 1. So my domain will become what? You divide throughout by 2. So my domain will become from minus pi to pi. So x over 2 is equal to tan inverse of 1. Correct? So 0, pi by 2, pi, 3 pi by 2. Correct? So one is positive, all silver teacups. One is positive here and here. Correct?
Right.
Now we are looking at 1. We are looking from minus pi to pi. We are looking from, let's say, from minus pi. So from here to go, this is minus pi to pi. We are looking from minus pi to pi. So this angle will be pi by 4. So x by 2 is equal to pi by 4. 45 degrees, that is. Okay, and there's no other angle coming in the positive side because
There's
here
4 angles.
only one came in. Na? This one won't come in. Na? This one, there's no other angle. Only this one came in the positive one.
What? Ah, sorry.
Pi is 180. Yes, you're right. The other one is here. So that's minus 3 pi by 4. So you multiply. So x is equal to 2 pi by 4 and minus 3 pi by 4 into 2. So pi by 2 and minus 3 pi by 2. That's your answer. What you need to do is you have this expression minus 2 cos square x plus sin x. Pay attention, please.
Yeah, sorry.
Plus 3.
I have to move 3 to the other side.
No, there's no other side. It's an expression.
Ah.
There's no other side for an expression. You know that cos square x plus sin square x is equal to 1. So what is your cos square x? Can you write it as 1 minus sin square x? So I'll write your cos square x as 1 minus sin square x plus sin x plus 3. So when you open the brackets, minus 2 plus 2 sin square x plus sin x plus 3. So that is 2 sin square x plus sin x plus 1. So you got everything in, so you have replaced your cos square x by 1 minus sin square x. Hence solve this equation. Now you have to take your equation. What's your equation? Minus 2 cos square x plus sin x plus 3 is equal to 2. So we proved that this is same as this. So that's what I'll replace. I'll replace this, which is here, by this. So this will come here. Okay? So 2 sin square x plus sin x plus 1 is equal to 2. So 2 sin square x plus sin x minus 1 is equal to 0. So 2y square plus y minus 1 is equal to 0.
And then you just do what we
2 ones are, remove 2y common, y plus 1, remove minus 1 common, y plus 1 is equal to 0. So 2y minus 1, y plus 1 is equal to 0. So 2y minus 1 is equal to 0 or y plus 1 is equal to 0. So y is equal to half or y is equal to minus 1. Substitute. What's your y? Sin x. Sin x is equal to half or sin x is equal to minus 1. So yeah, it's a long sum.
Very long sum.
Very long sum.
I don't know.
No, we'll finish it. I'll finish it, then you can go home and do it.
Okay.
So what is it? All silver teacups. So sine is half here and here. So x is equal to how much? 30 degrees or 150 degrees. Correct? Isn't it radians? Wow. So if you refer radians, pi by 6 and 5 pi by 6. Now minus 1. So minus 1, if you look at your unit circle.
Oh, it'll go like that.
1, 0, 0,
Yeah,
1,
it's down there.
minus 1, 0, 0, minus 1.
Ah, but
So
luckily
3
there's
pi
only
by
one
2.
solution.
So minus 3 pi by 2. So that's how you do this.
Yeah.
This is how you do the lovely sum.